actual temperature of the water, 28 degrees, 30 degrees up here, and not much variability during the year. What happens is that there are small gateways through which that water escapes from this circulation pattern. So we see that there's a current comes down here, the East Madagascar current, the Mazin Channel comes around here. So we can see that warm water is trying to escape from Indian Ocean. It gets in through these little gateways here, it gets trapped in sort of these little mini gyres, these eddies, and the heat is being transferred down here. It then hits the Agulhas current. Now the Agulhas current is a western current, a western boundary current, so that has the capacity to transport through here. So these are places that are trying to measure the amount of water and the nature of the water that's being actually transported. And the most of this water comes down through here. There's a very large amount of water. The figures that are suggesting, so you can, it's about 17 spheredrops, which is, no, sorry, Agulhas current 70 spheredrops. Now 70 spheredrops is a very large amount of water, 70 million cubic metres of water. Compared to the thermohaline circulation, I think is only in the 20s or 30s, I can't remember the figure. But effectively, there's a huge amount of water being transported along here. Now, when it gets to off southern Africa, some of it is retroflected back, so effectively it's pushed around by water down here, and the current going round here. Remember, this is the westerly, so this water's going this way, so it's pushing against it as well, and some of it returns into the Indian Ocean. The key question is how much water and when these rings form and leak out into the Atlantic Ocean. And at the moment, it's clear that this pattern happens. And one of the arguments for the past is that what happens is that when we go into what drives going into a cold phase and the ocean's cooling in the North Atlantic is that for some reason this current weakens, this heat doesn't get into the Atlantic, stays within the Indian Ocean. And effectively this process of leakage of the Agulhas water stops. And as soon as that manages to get back into there, the whole belt is turned on, the heat is transported right up through the Atlantic into the North Atlantic, the conveyor belt starts again or strengthens up, and the heat is brought back to the North Atlantic. So the question really that this paper seeks to establish is, what is the nature of this process that goes on around here, and what do you need to cut it off, and what do you need to strengthen it? And what is likely to happen, how can we explain it in the past? And we can use past records from the marine sediments. So if you go to marine sediments, we haven't done marine sediments yet, but if you go into ocean sediments here, the sediments, we can track from the sediments the temperature of the water and the salinity of the water. So what we can do at sites around here is determine the past history of how much water has leaked out through here. And the underlying sort of thinking at the moment is that it is likely that when we talk about glacial interglacial cycles, one of the things that drives the strength of the glacial interglacial cycle is the ability of the northern hemisphere to steal heat from the southern hemisphere. And if you stop the northern hemisphere from stealing that heat, the northern hemisphere very quickly goes into a very cold condition. As soon as that heat returns, it will warm up. And although the ocean currents are a very slow way of moving heat through the system in real time, geologically that's not so short. So abrupt climate change could be triggered by cutting off this. So, if for some reason this were to slow down and cut off, and the heat's not getting in there, then the argument is that the whole of the Atlantic will cool, especially the surface Atlantic, and this will help to break down the thermohaline circulation. So abrupt climate change and looking at the thermohaline circulation has tended to look at the Arctic down it's tended to say, oh dear, what are we doing to the Arctic? The reality of it is that just as important may be what's happening in the Southern Ocean around here. And there is a southern polar front, rather like our jet stream and our polar front in the northern hemisphere. And it's clear that in colder conditions, the front moves northwards, and in warmer periods, the front moves southwards. It doesn't move a long way, but if this were to move just that far north, then this would be enough to reflect the Agulhas current back into there. That doesn't have to change its temperature, it just doesn't get out there, it just goes back into there and strengthens the zonal circulation. So effectively, what you're doing between a really cold period and a really warm period is cutting down the meridional transport. You're cutting down the ability of the Earth to transfer heat from the high to low or low to high latitudes. And you get a much more localized flow of water and a concentration of water in these areas. Much more uniform, less variety. And that can trigger quite large-scale climate variations and climate variabilities. So, with regard to the particular paper, what I'd like you to do is certainly to read the paper, but don't read it all. It's a hard paper. You can read page 1 and get an idea of this. The interesting thing about this is if you look at this diagram as well, we talk about leakages. We talk about the Agulhas leakage. There's leakage from the Pacific into the Indian Ocean. So you can see that heat does leak around southern Australia. It also comes through Indonesian through flow. That's more likely to always be there because it's not nearer, that's nearer the equator. But again, you can imagine that if that is cut down, the westerlies go further towards the equator, trapping the heat in here, you get a very different ocean system. So again, glacial interglacial cycle, you could conceive of this front moving up towards Australia and preventing Pacific water from getting into the Indian Ocean. So the Indian Ocean stays in its own form. So read page 1. Have a go at box 1, which is quite difficult, but which gives you an attempt to look at it. Read Agulhas system and ocean circulation. So that's around this particular thing. Don't read mechanistic linkages to climate unless you're feeling particularly strong and brave. That is a bit heavy, and I think you might find a bit difficult. Do read, though, the bit next to it, observed interactions with climate, because the character of these ocean masses has huge effects for terrestrial climate and atmospheric change. So, depending on the strength of the Agulhas current, depends on extreme rainfall events in Africa. There's a strong link with what goes on in the African, Eastern Africa in particular. As you move across, you then get into ENSO, and you get all the effects of ENSO and La Nina, El Nino effects. And so it's important to understand these linkages. So I would read the observed interaction with the climate, the suggestions that are there, and also then for the future, the facing uncertainties. We know therefore that the AMOC is influenced by Agulhas leakage, but we don't have a good idea of just exactly what the sort of effect is. One of the concepts about ocean and atmospheric systems is that, do we have stable states? If we talk about global climate and we talk about global atmospheric circulation and global ocean circulation, do we have a system over time that either we're in one state or another? We're in a stable state, varies, but we're in a stable state and this is what it's like. And when we get a change, we don't sort of change into a sort of bit of a mess or a bit of a mix of the other. We actually go from one state to another. And so do we, for instance, in recent geological time, have an Agulhas leakage state where we have an AMOC that works? And then we have a non-Agulhas leakage state, where there's a total